Hi there. Thank you for clicking on this video. This video lesson is going to cover something called completing the square, which I think is an interesting topic, even if it doesn't always get covered in your math classes. So maybe you're doing this because you're required to do it, or maybe it's part of an enrichment, or you're just curious. Either way, like this video if you find it helpful, subscribe to the channel for more math content, drop a comment or question below, and check out the other videos on the channel, including lots of our other quadratics videos. Now, what is completing the square? Okay, we're going to look at this a couple different ways in this lesson. It is a less common way to solve quadratic equations. It is a process that we go through. It does work, but it's not one of the common ways. The common ways that we solve quadratics are usually the quadratic formula and factoring, with square roots and graphing being kind of our backup methods. Quadratic equations by completing the square, not as common. However, it is used in some other areas, like what we call coordinate geometry. So if you are continuing on in math, you might see this when you study circles later on, and it'll be nice if you've seen the process before, rather than your pre-calculus teacher just kind of like dumping it on you, or your algebra 2 teacher might dump it on you. It is also used to derive the quadratic formula. So if you think of the quadratic formula, if you have a quadratic ax squared plus bx plus c equals 0, and most of the time your teacher just hands you this formula and says, good luck with that. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And students generally are like, well, my math teacher seems like they know what they're talking about. I guess I'll just use this formula. But you might wonder at some point, where did that formula come from? How did you take ax squared plus bx plus c and figure out a way to get the x by itself? Well, the process that's used there is completing the square. And I'll try to link, I have a video where I go through that, where I start with the ax squared plus bx plus c equals 0 and end at the quadratic formula, and I go through the completing the square process. So I'll try to link that maybe at the end of the video somewhere, so you can check that out if you're interested in how this process is used to come up with that formula. Now, completing the square does work all of the time. So there's no kind of equation where it doesn't work. It's not limited like factoring is, or using square roots, or even graphing, depending on the type of solutions you have. Completing the square is one of those strategies that always works. I guess we kind of know that because the quadratic formula always works and they pretty much come from the same spot. But it only works well if the a value is equal to 1 and your b value is even. So if you've got something like x squared plus 10x minus 3 equals 0, and that a value is equal to 1 and your b value is even. Now, does it work when you have an odd number for b? Yes, it will, but your numbers get really awful. Does it work or is there a way to make it work when you have a number other than 1 for your a value? Yes, but nobody wants to do that. Okay, so it does have some limitations to when this is actually a good method to choose. Now, the process is going to feel very random to you. Okay, so like if I just launch into do this, and I give you the steps, which I absolutely can do, and I've done it with my classes in the past, but not anytime recently. But it's going to feel very random. It's going to not have any grounding in what are we doing? Why does this work? And I don't want to teach that way. So there is a video lesson, like a little side lesson, and I'm going to link that in a card in the upper right-hand corner. And I want you to stop this video right now, click in the card that you will see or might see appearing up in the corner there. And it's only about a 6.5 minute video. So once you watch that video, then come back to this lesson. Okay, hopefully you did that. Okay, you went and watched the other video. If you did not, rewind this video, go find that card again, okay, and watch that. Don't shortchange yourself like 6.5 minutes to not know where we're going with this, okay? So we're gonna look at that first example from the video. And try to establish a process here. Now, what we have here, and I mentioned, I think in the other video, I'm gonna like screenshot this and give you a summary. The arrangement of the tiles on the left here is our standard form. So it's x squared plus 4x minus 1. The arrangement of the tiles on the right is the completed square. And you might look at that, again, if you didn't watch the video, you're probably definitely looking at it and saying, well, that's not the same group of tiles. Well, it is. Go back and watch the video. It's the same group of tiles because this group of +4 would cancel out with this group of -4, and then we would have the exact same combination left over. And this one is in completing the square form. So this right here is x, and then we have the 2, and then we have the same dimension going on our height. So the area there is x plus 2 all squared. It's x plus 2 times x plus 2. And then we have a -5. And we know they are equivalent because of the way the algebra tiles work, where we can see those 0 pairs. And so what we have here is 2 different forms of the same thing. This one has a beautiful completed square. So algebraically, without busting out your algebra tiles to do it, which is not a bad way to do it, but you might not always have them, or you might have some of the numbers that don't work out nice. We need to come up with an algebraic set of processes to do this. So here's what it looks like. You're going to take your b value and divide it by 2. So going through this example, so we have x squared plus 4x minus 1. And if you recall from the video, in order to complete the square, if you want to keep the dimensions square-y-ish, you have got to add the same number of x's to each side. And I think I did that a couple places in the video where I said if you try to put 3 x's on one side, you're not going to get a square that way. The only way you're going to get a square is to take however many x's you have and divide them evenly so that you have the same number that's going to go on the width as you have going on the height. So if you increase this by a little bit and this by a little bit. So I'm going to take my b value, 4, that tells me how many x's I have, and I'm going to divide that by 2, and that number right there tells me how many x's I am going to have on each side. So that represents this 2 right there, okay, which appears right here when we go to find the area. Okay, so divide the x's by 2, that's where that number comes from. Now, what that leaves us with is this gap, okay? And I think I mentioned in the video, we have an incomplete square. So we end up this gap here. And this gap is also always going to be a square. Why will it be a square? Because we evenly divided our x's, so the width of that square and the height of that square are always going to be the same. Well, what's the width and the height? It's however many x's we have. So in this case, it's a 2. So what I do next, if you look at step 2, is I square the result. 2 squared is 4. And what that tells me is how many pieces I need to add in here to make my very visual square complete. So I'm going to need to add 4 into this position to make the square complete. So here's what it looks like algebraically. We're going to add and subtract that number. So right here next to the 4x, I'm going to change up the colors so we can see it. I am going to add 4. Here's the problem. I cannot just add 4. Okay, if you go back over here and look at this, like the presence of these positive tiles changes it. So if I add 4, I also have to subtract 4 or add the -4 to balance it out. And so what we essentially do here is we're going to add 4 and subtract 4. So this is what it looks like algebraically. This is what it looks like with the tiles. Add 4, subtract 4. Now here's where it gets cool. Okay, if I look at this piece right here. Now, in the past, when I have taught this to my students, I've said, well, now you need to factor that, and nobody's happy to hear that. But if you picture this the right way, okay, you don't need to do any factoring because x squared plus 4x plus 4 is this piece, x squared plus 4x plus 4. And what do I know about that area? Well, it is x plus 2 times x plus 2. So instead of going through the hassle of factoring it, I can just rewrite that as x plus 2 times x plus 2, or x plus 2 squared, for the width times the height. And then minus 1 minus 4, or negative 1 plus negative 4 is negative 5. And there we go. So once you complete the square and you figure out what's that number there that I have to add in, now instead of factoring it, you just have to picture, okay, what does that square look like? And what will the dimensions of that square be? And there's our algebraic process. Okay, let's take a look at that second example. All right. So this one, the polynomial we were looking at was x squared minus 2x plus 3. And over here, we have x, and then just make sure we're getting our dimensions right, x minus 1. And this dimension here is also x minus 1. So the area here is x minus 1 all squared. And then we have the plus 2. And this one's a little bit more obvious that they are equivalent, okay? Because you have 1 blue tile, 2 red tiles, 3 yellow tiles. Like, it's very clearly the same number of tiles, just arranged differently on the page. And we want to practice that system. And I know in the video, when you're doing this, you could just grab one of the ones and throw it in there. And I said, don't. Like, yes, you could, but it messes up our process that we want to establish, because we know not all of them work that way. Like the last one we did, that you couldn't do that. And we don't want to leverage little tricks that only work some of the time. We want to make sure that whatever we're doing is going to be something that universally works. So that's why we just don't do it that way. But the first step is going to be the same. Regardless, you're going to take your b value, which in this case was a negative 2, and divide it by 2 to get negative 1. And that number is that split. You're going to take your x's and split them in half. Okay, and so that number, negative 1, tells me what I have going on the sides of my square there. So it's always going to end up in that position. It will be x and then plus or minus whatever you got right there. Now, when we do that, we have an incomplete square. It is not completed. So we are going to have a 1 by 1 square. And so the process is square that result. So we take the negative 1, square it to get 1. That comes from negative 1 times negative 1. Okay, there's your geometry. Negative 1 times negative 1. It gives you positive 1, and it tells you what you need right there. So we are going to add that number in. So we're going to add the 1 in. And again, this plus 1 represents this plus 1 right here, what we are adding in to complete the square. But we cannot just add in stuff, we also have to subtract it. So if I add a plus 1, I will need to subtract a 1 from my group of 3 out here in order to make sure that I'm not changing it. It's adding that 0 pair in. Now, if I lost you on that, you need to go back and rewatch that video, okay? Because we did it out with the algebra tiles. This piece right here is my completed square. Let's take a look at it. It's x squared minus 2x plus 1. So could you go and factor it with your area model? Like, sure, but it's done if you did it this way. It'll be x minus 1 times x minus 1, or x minus 1 squared, and then 3 minus 1 is 2. So there's our algebraic process tied in with the geometry and the algebra tiles, so that you've got 2 different ways to visualize what we're doing. Now, I mentioned that this strategy really only works well when your b value is even, and that's because when you divide by 2, you want to come up with a nice number. Now, if you have an odd number, okay? It really doesn't work with the algebra tiles unless you want to cut a tile in half, which in theory you can do, okay? You could cut one of the tiles in half and then put like a half a tile on each side. Algebraically, it's no big deal. You'll have something with a decimal or something with a fraction, but it does make the rest of the work kind of awful because then you end up with like fractions in your squares, and generally we just don't want to deal with it. It's not that it can't be done, it gets kind of messy. So how does this actually help us solve equations? All right, we are going to complete the square to change the form, and then we're going to use square roots to isolate the x. So I've got two examples here. We're going to work through two examples. So I have x squared plus 6x minus 4 is equal to 0. So remember that first step, take your b value and divide it by 2. Okay, and what that is telling me is it's telling me what size my square is. So if you wanted to picture it, it's going to tell me that I have 3 of those rectangles on either side. That's what it's telling me. Now I'm going to take the 3 and square it. And that tells me this size right here. This is going to be 9 squares deep. So to complete my square, I have to add 9. So I'll have x squared plus 6x plus 9. Okay, so that's what I'm adding. Now I have the minus 4, and remember, you can't just add 9. If you add 9, you're going to have to add the 0 pair with them. So you'll have to subtract 9. So we're going to add the 9 and subtract the 9. This right here, okay, this piece right here, that's your square. So that's going to be x plus 3 all squared. Negative 4 minus 9 is negative 13. Okay, and that's that completing the square process. So I took the x squared plus 6x minus 4, I completed the square. So here's where we go from here. I am going to add 13 to both sides. So I get x plus 3 all squared equals 13. And now I actually have this in a form where I can use a square root. So watch how this works. This is pretty cool. I'm going to take the square root of this to undo the squaring. When I take the square root of this, I just have to add that plus minus because it could be positive or negative. That's squared. The square root of something squared is just the something. So that would give me x plus 3 is equal to plus or minus the square root of 13. And now to get x by itself, all I need to do is subtract 3. And so that 3 minus 3 is 0. And I'm just going to put that negative 3 out front. So it's negative 3 plus or minus the square root of 13. And there's my solution to the equation. Ta-da! Okay, maybe you're not that. I think it's pretty cool, but I'm nerdy. So, all right, let's look at the other one. So same process. So we're going to do x squared minus 8x. I'm going to take that negative 8 and divide it by 2. Okay, negative 4. And what that tells me is that what I got going on out here is negative 4 going this way and negative 4 going that way. And so my side length is going to end up being x minus 4 in that area model. And then, like, I'm aware this is super crowded here. This chunk right here is the missing thing. That's like what we need to complete the square. Okay, we're going to need some stuff to complete the square. Well, how big is that? That is going to be negative 4 all squared. That's 16. So my magic number, I'll change the color up on this one, that I have to add here is 16. And I cannot add a 16 without also subtracting it. Okay, this piece right here, okay, that's my x squared minus 4x plus 16. I don't have to bother factoring that. That's x minus 4 times x minus 4, also known as x minus 4 all squared. And then negative 3 minus 16 is negative 19. Adding 19 to both sides. So I get x minus 4 all squared equals 19. And now I can kick in my square roots. So I'm going to undo the squaring here with a square root. Just remember when you square root the other side there, it is plus or minus because it could have been either. That leaves me with x minus 4 equals plus or minus the square root of 18. And then to get the x by itself, we're going to go ahead and add 4 to both sides. So x is equal to 4 plus or minus the square root of 19. And again, this strategy will work for like all kinds of quadratics. Just the arithmetic, you could end up tangled in a ton of fractions. Okay, so let's kind of summarize what we got going on here. There are 5 ways to solve quadratics. You've got your square roots, and that only works if b is equal to 0. You can use the quadratic formula, which always works, factoring, which sometimes works, okay, if it is factorable. Completing the square always works, but you want b to be even and a to be 1 because you just need it. And then graphing, you can always graph your quadratic and look for the x-intercepts, and that works some of the time. It doesn't help if the answers aren't real, but we haven't really talked about that yet. Now, completing the square is sometimes not taught because it is not needed to solve any specific type because you've got the quadratic formula. Okay, and it does not present a clear advantage. So factoring doesn't always work, but it does present this really clear advantage in how clear it is. Square roots, it's kind of limited, but when it does work, it's so much easier than factoring or the quadratic formula. Completing the square always works, but it just doesn't have like this great clear advantage over other methods. So a lot of times, if you don't need to know it, we don't cover it. However, it is used in other places in math, as well as a method for changing between forms of a quadratic, which can come up later. So essentially what we were doing there was we were changing a quadratic from standard form to what's called vertex form. All right, so that's it. Like this video if you found it helpful, subscribe for more math help, ask a question or drop a comment to engage, and check out the other videos on the quadratics playlist or some of the algebra tiles and Desmos videos, and I will try to link over to now I don't remember what the other video was that I was going to link to, but hopefully you do. I will go look it up and I will go link to it. And check out the practice set so you can get a chance practicing the completing the square on your own. I'll see you in the next video.